Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afizani binti Ahmad. So today I want to present my extended abstract about the climate change on agricultural water resources. Here the outline of my presentation. The summary on journal that I choose. Climate change is having a considerable impact on the availability of water resources for agricultural production on the North China Plain (NCP), where the shortage of water is currently disturbing the stability and sustainability of agricultural production with respect to the drying tendency since the 1950s. However, although potential evapotranspiration (ET) has shown a decreasing trend under climate change, actual ET has slightly increased with an acceleration in hydrological cycling. Global Climate Model, which is GCM, sample projection predict that by the 2050, the increased groundwater demand and intensified ET resulting from global warming will reduce water resources surplus precipitation ET about 4% until 24% and increase significantly the irrigation water demand in crops growth period. The NCP is one of the China's premium growing areas. Although it represents about 50% of the entire country farmland, it produces approximately 75% and 35% of China's wheat and maize. However, it has a historically low agricultural yield due to adverse soil conditions, which are saline, alkali, poor irrigation and drainage facilities. Since the 1950s, considerable efforts have been made to consolidate and improve and by constructing hydraulic engineering and irrigation facilities such as drainage and irrigation ditches, reservoir, and riverbank. The simultaneous application of synthetic chemical fertilizer, introduction of new cultivar, and improved agronomical practices have also contributed considerably to agricultural development on the NCP. As a result, high crop productivity with low interannual variability has been maintained since the 1980s. Based on this channel, the impact of climate change on agricultural water resources includes on the ET, which is evapotranspiration, runoff, and the water budget. At first, let's focus on ET. Annual ET and soil moisture decrease, which is associated with a latitudinal zonality of precipitation and air temperature. In the long term, ET and soil moisture trend will mainly be affected by the potential ET trends and agronomical practices. Wheat and summer maize have increased. Under climate change scenario, climate warming will necessitate reduced crop growth periods. Therefore, without adopting cultivars with higher thermal requirements, both at the yield and total water consumption will decrease. Next, on the runoff, in the northern part, runoff will be enhanced at a higher magnitude than precipitation owing to the relative low runoff coefficient. But in the southern part, the increment of runoff will be lower than that of precipitation. However, there may be a decrease in available water resources owing to the negative impact of intensified ET event with the projected future increase in precipitation. And the last one on the water budget. A greater amount irrigation will be supplied to agricultural production from groundwater exploitation and transfer from the western mountainous basin and the south to north transfer channel to sustain a high crop production. Alright, let's move to the adaptation strategy of agricultural system to climate change. reduce agricultural water consumption by settling the zone area of winter with future climate change projections will exaggerate water shortage in the Head River basins. Winter wheat is the principal consumer of irrigation water, and thus the area of winter wheat soon should be reduced in areas where groundwater is overexploited and the amount of surface water is insufficient. In this study, simulations were conducted using several adaptation strategies to target groundwater equilibrium, create new crops varieties with enhanced stress tolerance to heat and drought, particularly for winter wheat and summer maize, using crop variety with a higher thermal tolerance and a longer growth period may effectively improve the potential yield. But as plants will require more water, the demand for irrigation will increase. However, by using higher stress tolerance varieties, crops can be sown more densely to derive better grain yields per unit area. With the greater tolerance of individual plants for certain critical stress, the sowing date of winter wheat can be postponed by about 1 week, and higher yield can be achieved by applying water-saving techniques and other agronomical practices. Enhanced drought and heat tolerance in rain crops will also enable higher productivity with a longer growth period under climate change. As a conclusion, the potential demand for crop irrigation water will increase under climate change projection. However, the ability to expand irrigation will be constrained by the availability of water resources. Irrigation supplies are particularly vulnerable to shifts in precipitation, water cycling, and the demand of water from non-agricultural sector on the North China Plain. That's all from me. Thank you, and let's move to Q&A session.